Hey there, hey everybody, and so today you're going to be taking notes on the distributive property. Now, I didn't give you note sheets, so you should be taking your own notes as we go along. And I am going to be checking those notes to make sure that you've done it. But we're in section 1.7, the distributive property, and I know I've been jumping around a lot because a lot of these topics I know you saw last year, so I'm reviewing the ones that are the most important. So today we're going to be using the distributive property to multiply, and we're going to be combining like terms, so that we can get to doing some real solving equations next week. Okay, so using the distributive property, you multiply each term inside the parentheses by the number on the outside, paying close attention to whether the number is negative or positive, because that may change things inside the parentheses. All right, so let's look at some basic examples. So here's our first example. Very, very basic. It says simplify using the distributive property. So we have 2 parentheses x plus 5. So that 2 has to get distributed to everything within the parentheses. And I want you to think distributive property, just multiply it. So this would give me then 2x plus 10. Okay, the directions would say simplify. We're going to talk about how we use this when we solve equations later on. All right, let's look at the next example. The only difference here is that I put the number on the back side. But remember we said that the commutative property of multiplication allows us to flip these two. This is a product and this is a term and this is a term. When we multiply them, we can actually flip them around. So this 8 can get distributed here and distributed here. So we would be left with 8 plus 16x. So just note that it doesn't really matter where the number is. We're going to see it more like this, but this could happen as well, okay? All right, so let's try a couple more. I put a 3 on the outside, so 3x plus 1. It's 3 parentheses x plus 1. I'm going to go ahead and I'm going to distribute the 3, and I'm going to be left with 3x plus 3. One of the common mistakes is to just multiply it to this x. So I'm using these arrows to just kind of help me, and I actually do that a lot, just to make sure I don't miss any steps. Those of you that really don't want to make those careless errors you make, the arrows may help you. All right, on this next one, now that 7's on the outside, we're not going to let it throw us off. So 7 times x minus 2, it's going to be multiplied to the x and to the negative 2. So we're going to get 7x minus 14, okay? All right, I want you to look at the next one. I'll give you a second to write it down. 2 plus 5x times x, okay? 2 plus 5x times x. Okay, so now this is where we have to use some of those skills we learned last year in pre-algebra. Again, that x is going to get distributed to everything, so it's going to get multiplied to everything within the parentheses. So the first term is going to become 2x. X times 5x is going to give me 5x squared, and because this is positive, that would be positive. So we just want to make sure we realize that when we multiply 2 variables with the same variables, that we're going to add the exponents. So there's an exponent of a 1 here and a 1 here, and that would change it to an x squared, okay? All right, I'm going to go on, actually. All right, let's now try with negatives. So I have a negative 3 times parentheses x plus 4. So that negative does change things, because when we multiply, you have to remember when you multiply a negative to a positive, you get a negative. So negative 3 times x would give me negative 3x. And then negative 3 times positive 4, negative times positive is going to give me negative 12. Okay? So notice that everything inside, every sign changed. All right, we've got y plus 5 parentheses times negative 4. Again, it's in the back, but the commutative property of multiplication allows me to flip this around. So I'm going to multiply it to the 5 and to the y. So negative 4 times y would give me negative 4y. And then negative 4 times positive 5 would give me negative 20. All right, one more. Looking at this one, we have to be really careful, because there's this negative on the outside of the parentheses. And what's really happening here, guys, is really there's a negative 1. But we don't write that. So we say we have to distribute the negative through. If you want want to go ahead and put a 1 there just so you see what happens, that may be helpful. So I've got negative 1 times 6 minus 3x, but that negative changes every sign within the parentheses, so we would end up with negative 6 plus 3x, because now we have a negative times a negative yielding a positive. All right, let's see if I can scroll on here, because I was having trouble with that a little earlier. All right, last one. Parentheses x minus 1 times negative 9x. Okay, so we were going to distribute this 9 through. I switched colors on you. So I've got a negative 9x times x, which is going to give me negative 9x squared. Then I have a negative 9x times a negative 1. Again, there's that negative times negative. Be careful, and I'm going to get a positive 9x. Okay? All right, so hopefully you're feeling pretty good with the distributive property. Couple of vocabulary terms we want to make sure that we know. We need to know what a term is. So basically, a term is just a variable or a number. Or a number, okay, or a constant. But like I would say, if I gave you 2x plus 5, I would say that this expression has two terms. This is a term, and this is a term of the expression, okay? A constant, by definition, says a term that has no variable. A term that has no variable. So in this example that I drew 2x plus 5, the constant would be, oops, you can't read that. The constant would be 5, okay? Something that can't change. All right, coefficient. The coefficient is this is what the book tells you. It's the numerical factor of a term. Okay, so the coefficient up here, 2x, coefficient's 2. It's the number in front of the variable. The number in front of the variable, okay? And the most important thing that we're going to be doing in the next couple of weeks is we're going to have to be able to recognize like terms. My definition of like terms is anything that has the same variable raised to the same exponent. The same variable raised to the same exponent, okay? So I'm going to give you a second to write that down. Doing pretty good on time today. Trying to keep it short for you. All right, so let's just make sure we understand like terms. And again, you can always rewind this. All right, are they like terms? So 7a and 3a, are they like terms? They have the same variable. The exponent in this case is both a 1, so yes, they're like terms. 4x squared and 12x squared. Same variables raised to the same exponent, like terms. All right, 6ab and 2a. So does this term and this term have the same variables? Well, this one's got a b and this one does not. Even though the a's are the same variable raised to the same exponent, in order for them to be like terms, this one would need a b. So no, not like terms, okay? And here's one, x squared and x. Can I add them? Can I add them and say they're x cubed? No, they are not the same variable raised to the same exponent. This one has an exponent of a 1, which is hidden. This one has the exponent of a 2. So no, they are not like terms. The great thing about like terms, though, is when you have them, then you're allowed to add them together. So let's look at an example. Combining like terms. If they have the same variable raised to the same exponent, then you can add them. So, looking at this example, 8x plus 3x, 8 and 3 is 11. I add them together without changing the exponent, okay? I am not changing the exponent when I combine like terms. All right, looking at the next one, we look at our like terms. So 4x squared and negative x squared are like terms, so we can combine them together. The 2 is not a like term, so it must stay by itself. So this would then reduce, I've got a 4 minus 1, which is 3x squared. Okay, and I kind of, when I use it, I lose it. I kind of cross it off so I know I've used it. And then I've got a positive 2. So that would simplify to that. All right, a little bit harder. So here's a great example of using the distributive property along with combining like terms. Remember, our order of operations tells me that I have to multiply before I add and subtract. So looking here, I have 3 minus 2 times 4 plus x. So I'm going to distribute this negative 2 through my parentheses, or in other words, multiply. And I'd be left with 3 minus 8 minus 2x. Okay, combine the like terms. Well, you guys have to realize that numbers without variables are like terms. So 3 minus 8 is going to give me negative 5, there's that color again, negative 5 minus 2x. Okay, negative 5 minus 2x. And I'm going to throw one more in here, okay? How about this? 3x minus negative x plus 1. Okay? So what I did here was I put that minus in front of the parentheses. And again, following order of operations, I've got to deal with this multiplication. And there is a hidden 1 here that we talked about. So the first thing I'm going to do is I'm going to distribute the negative through, and it's going to change every sign within the parentheses. Okay? Then I look for my like terms. 3x and x are like terms, so I can combine them. So 3 minus 1 is 2x, and then I bring down that constant term again. So this is a two-termed equation. Coefficient to the x is a 2. The constant is a negative 1. The like terms were x, and like terms are things that have the same variable raised to the same exponent. Okay? So hopefully that is a good review of the distributive property. If you have any questions, do you have any questions that you want to post on Haiku? So if you have a question right now, I do want you to go to Haiku, because you're on Haiku. I just want you to type it in the comment section right under the video. Let's see if anyone can come up with a really good question or a harder problem that maybe we can try in class tomorrow. Okay? All right, guys, have a great night. Bye-bye.